All right, so this one looks a lot worse than it is. Keep in mind, you know, looking at this would probably work on the left side. It's more complicated, probably pretty easy to see that. But I'm going to need to get a common denominator in order to add those two fractions together. So what I'm going to do is remember that, you know, this is one factor, this is another factor. So I'm going to have to multiply my first fraction by 1 plus cosine of x over 1 plus cosine of x. And then I'm going to have to multiply the second fraction by 1 minus cosine of x over 1 minus cosine of x. Okay, I'm going to do this kind of in a couple of different steps here. So my first fraction, in the numerator, I would multiply 1 times 1 plus cosine of x to just get 1 plus cosine of x. And then I have 1 minus cosine of x times 1 plus cosine of x. Okay, then I have 1 times 1 minus cosine of x, and then over my common denominator. All right, next up, I want to combine my two fractions. So I get one big fraction. In our denominator, hopefully you're recognizing that is a difference of squares. So using a difference of squares, we could multiply that out to get 1 minus cosine squared. I'm going to go ahead and do that. Might be useful. In the numerator, I need to add like terms. So I'm going to add 1 plus 1 to get 2. And then I'm going to add that's not a highlighter, cosine of x minus cosine of x to get 0. So it's just 2 in my numerator. All right, and that's equals to 2 cosecant squared. So hopefully we can start to see that, you know, on the right side, we wanted a 2. Now we have a 2 on the left side. So we're getting closer. Now, 1 minus cosine squared. That, again, is one of your Pythagorean identities. So if you look at your Pythagorean identities, you should recognize that 1 minus cosine squared is just sine squared. So I can replace that 1 minus cosine squared with sine squared. Now, you know, I noticed that on the right side I've got cosecant squared, and on the left side I have sine squared. Most of the time we're changing things into sines and cosines, but this time I need to change sine into cosecant. So I'm going to use my reciprocal identities, and I'm going to write this as 2 over 1 over cosecant squared. Now, some of you might be able to do this a little bit quicker, but I'm just showing you why this works. Now, because I have a fraction over a fraction, I'm going to write that as 2 over 1 just to make my life a little bit easier here in a second, because I want to rewrite that fraction over a fraction as a multiplication problem. So I'm going to write 2 over 1 times the reciprocal of 1 over cosecant squared. So that's cosecant squared over 1. Oh, that's really nice. And we've got it. All right, next up. So, you know, you look at this and you're like, I don't know which side is easier. But I would say with cosine of 2x, remember there's 3 options that we can choose for that. So we'd have to sort of guess and check which one would actually work. But with sine of 2x, there's only one possibility. So that's why I'm going to lean towards working on the right side this time. Okay, so first thing I'm going to do is I'm going to change sine of 2x into what it's equal to by using my double angle formula. So that's 2 times sine of x times cosine of x. Okay, now let's go ahead and change tangent, because again, I like everything to be in terms of sine and cosine. So I have 1 minus cosine of 2x equals, let's make that sine of x over cosine of x. And we've got 2 sine of x cosine of x all over 1. So what we're able to do here is we're able to take away one of the cosines. Now this is where it gets interesting. So what I have left is 2 sine squared of x. Now at this point, you might be stuck, and that's a very real possibility. This is one of those problems where you might get to a point, no matter which side you work on, and you just get stuck. So here's what I would suggest. You are allowed, make it the exception, not the rule, okay? But you are allowed to stop working on one side and say, okay, I'm going to move to the other side now and just do work on that side. So I'm going to stop doing anything to the right side, and I'm going to look at the left side. So remember our 3 different versions of cosine of 2x. We want to pick the one that results in a sine, right? So looking at our 3 possibilities, we have 1 minus 2 sine squared. That sounds like a good possibility. So I'm going to replace that cosine of 2x. Let me do this with my colors here. So I'm going to replace this with 1 minus 2 sine squared of x. Okay, now I'm going to go ahead and think about just simplifying the left side here. And this is very similar to a previous problem. 1 minus 1 is going to be 0. And then we have negative 2 sine squared. So that's just positive 2 sine squared. And we're able to show that the two sides are the same. Remember, I'd like you to make this the exception, not the rule. But if you do choose to work on a different side, you just have to make sure you pause work on the other side. Do not work on both sides at the same time. All right, next up. So this one may have stumped you a little bit, and this is very similar to, I think, 14. But look, it's just like if you ran across something like this, x to the fourth minus y to the fourth. That is actually a difference of squares, even powers, and you have a minus sign. So you could rewrite that as x squared minus y squared times x squared plus y squared. So I'm going to use that approach to rewrite the left side of my identity. So I can rewrite that as cosecant squared of x minus cotangent squared of x times cosecant squared of x plus cotangent squared of x. Now again, sometimes it looks like you made things worse, but remember the cleaning out your closet analogy. Sometimes things have to get messy before they get cleaned up. So now I'm going to look at this, and I recognize that we have some potential for using our Pythagorean identities. So cosecant squared minus cotangent squared. Well, this entire thing right here is just 1. All right, so now I've got 1 times cosecant squared plus cotangent squared. Now, here's the thing. The way that's written is not a Pythagorean identity. However, I noticed that on the right side, I want only cosecant squared. So I'm going to focus on how I could change this cotangent squared into something with cosecant squared. So when I look at, excuse me, my Pythagorean identities, I recognize that cotangent squared can be rewritten as just cosecant squared minus 1. Okay, so let's do that. Let's rewrite that cotangent squared as cosecant squared minus 1. Well, now, add like terms, you've got 2 cosecant squared minus 1, and that's exactly what we wanted. All right, one more for this, and then we'll go to another video. Once again, you've got a sum and difference happening here. So looking at your paper for cosine of u plus v, you should see what I've written in green. So I'm going to use that, but I'm just going to replace all of my u's with 180 and all of my v's with x's all through the entire equation. So instead of cosine of 180 plus x, I'm going to have cosine of 180 times cosine of x minus sine of 180 times sine of x. And I have to show that that is going to simplify to be negative cosine of x. Again, you get to this point when you use sum and difference, this is going to almost always happen where you have a couple of values that you can actually look to your unit circle for. So we look at the unit circle, and hopefully we recognize that the cosine of 180, is just negative 1. And we recognize that the sine of 180 is 0. So when I rewrite this, I'm going to have negative 1 times the cosine of x minus 0 times the sine of x. And I've got to show that that equals negative cosine of x. Well, that's a pretty simple substitute or simplification at that point. So negative 1 cosine of x, yep, that is going to be negative 1 cosine of x.